Welcome to EZMathTV. We're going to graph a polynomial today, not using Excel, but we're going to use Desmos, a tool called Desmos. And this is going to have some flexibility for us in terms of other things that we can do as well. So the polynomial we're going to look at is a function f of x equals 2x to the fourth minus 11x squared plus 60. And the first question we're being asked is, does the function have any zeros? And if it does, we're going to just approximate them using Desmos. And then we're going to make a change to that. We're going to change the 60 to a 10. And we're being asked then to evaluate, which means to calculate the value of something. And we're being asked to evaluate 2x to the fourth minus 11x squared plus 10 for certain values of x. And those values of x are going to be going from -3 to +3, and we're going to want to increment them by 1/2. So you're basically adding a half to every value of x that you include. So we're going to make a table in Desmos for that. So you're going to get to see how we can make graphs look more appealing and make the graph look more usable in Desmos, but also how to create a table of values. All right, so both of those things are going to be done today. And let's move this off to the side. And here's our function, 2x to the fourth minus 11x squared plus 60 equals y. So I've typed that into my formula bar over here on the left, and we are in the Desmos graphing calculator, but I don't see a graph here. So on your mouse, if you happen to have a scroll wheel on your mouse, you can zoom out and zoom in. Otherwise, you have to use the plus and minus keys up here. But, if you don't see the graph appearing, just keep going, and then finally we see it up there at the top there. And notice it's very compact. It's very elongated. That's what happens with polynomials, especially the higher the power of x, the more vertical it looks. It's going to be very vertical up and down. So there's a button up here on Desmos where you can change some of the graph settings. And if you click on that, notice that we have the x-axis showing, it's on display, and we have the y-axis showing, it's on display. And but we don't need all these values of x. The x values that we need probably only go from, say, -10 to +10. And I don't even know if we need that many, but let's just start with -10 to +10 here on the x. And that already made things better. But I also am going to change the y-axis to start with -10 and go only up to +80 because I don't need all those values above that. Anyway, so those are just different like lowest value and upper value that you can actually type in so that you can see the graph a little bit better. And I would encourage people to play with those numbers a little bit just to see like how that changes the appearance of your graph so that you can see what's going on. And then when you're done typing, you can just click on that little wrench symbol again, and it will go away. But you can also zoom in and zoom out a little more if you want. But I wanted to be able to see where the x-axis is. So there's the x-axis down there near the bottom. The entire graph is above the x-axis, but it does have like some relative minimum. And there's two of them, and then there's also a relative maximum here. But all of those are way above the x-axis. We don't ever see the graph going below. So when we answer the question, does the function have any zeros, the answer to that question is no, because the entire graph lies above the x-axis. So now we're going to change the number 60 to the number 10 in our in the expression. So it's still a function that we're looking at, but we are interested in the expression on the right, the 2x to the fourth minus 11x squared plus 10. And we want to know how it changes in value when x goes from -3 to 3. So we're going to do that in the form of a table, okay? So let's go ahead and change the 60 to a 10. And I'm actually going to zoom in even more here so that I can see the x's from -3 to 3 even better. And when I go over here, when I want to put a table in, I have this function selected, and then I click on the Edit List button up here, and we want to click on the table icon to create a table. So the default is that the table is going to go from -2 to 2, and it's going to increment by 1. So we want to start with -3. And then we want to go to -2.5 because we're going up by a half. And then we're going to go to -2. And then I'm going to hit enter, and I want you to see what happens to the next value when we do that. So hang on, that didn't do it that time. Try it again. Okay, let's just type in a few more values here then and see if we can get the function to do what we want it to do. So I'm going to hit enter. And now that I got rid of all those rows below, it's kind of figuring out the pattern that I want the x's to follow. But I had to delete those rows. I didn't realize that, but I had to delete all those rows below. And now we're going to get all the x's that we want. And I'm just going to all I did was keep hitting enter until I get to x equals 3. So -3, -2.5, all of those values up to x equals 3 are all now plotted on the graph. And if there's any that I'm interested in seeing the label for, I can actually just click on as many of these as I want to see what the actual value is there. And lo and behold, that's just a selection of the points. But these are all the exact numbers that when you plug in those values of x, this is the value of y that you get as your value of that expression, 2x to the fourth minus 11x squared plus 10. So anytime you're being asked to evaluate an expression, you can type it into Desmos in the form of a function. Just set it equal to y, and then create a table for yourself, and you can evaluate the expression for as many values of x as you want. The thing that Desmos will also do is approximate where our x-intercepts are. So let me, I want to remove those labels that I've clicked on. So all the labels are gone. I just want the x-intercepts now. So if I go over here and I click on the points where the function crosses the x-axis, these are only approximations for the x-intercepts or the zeros of the function. If I wanted exact numbers for these, we would need to go to wolframalpha.com and type in our polynomial expression and ask wolframalpha.com to factor it for us, and then also to solve, set it equal to 0 and solve. So we're going to see that as well in a different video, but that's if you want an exact answer. These are just going to be approximations here, okay? because the exact answers have square roots in them. So anyway, like, subscribe, comment down below if you're finding these videos helpful. And our next video is going to just kind of summarize everything that is important to know about polynomial expressions, polynomial equations, and polynomial functions. Those three things are all tied together. So I'll see you in the next video.